Welcome to the Virtual Tutor series on Core Mathematics for Senior High Schools. In this lesson, we cover zero and undefined algebraic fractions. This happens to be the final topic in our series of lessons on algebraic expressions. If you haven't watched our previous lessons on algebraic expressions yet, I highly recommend that you do so, as that will help you understand this lesson better. Kindly take your book and pen as you follow along. We begin with zero algebraic fractions. We know that 0 divided by any non-zero number is 0. Therefore, any algebraic fraction of the form f of x over g of x is 0 if f of x is equal to 0. In other words, since 0 divided by a non-zero number is 0, an algebraic fraction can only be 0 if the numerator is 0. We can therefore determine the value or values for which a given algebraic fraction is 0 by simply equating the numerator to 0 and solving for the variable. The proof of the pudding is in the eating. Therefore, let's have a look at the following examples. Find the values of x for which the following fractions is 0. Solution. Example 1. X minus 3 all over x squared plus 5x minus 6. As stated earlier, an algebraic fraction is 0 if the numerator is 0. Therefore, we equate x minus 3 to 0. The next step is to solve for x. We can simply do this by adding 3 to both sides of the equation. This gives us x is equal to 3. Therefore, the value of x for which the given fraction is 0 is 3. This can be verified by putting 3 in place of x in the above expression. Example 2. 6x squared minus 17x plus 12 all over 6x squared plus x minus 12. Again, let's equate the numerator to 0. So we have 6x squared minus 17x plus 12 is equal to 0. Now, the left-hand side of the equation is a quadratic expression. So what we have to do is to find two factors of the product of the coefficient of x squared and the constant term, which will sum up to the coefficient of x. The coefficient of x squared is 6. The coefficient of x is negative 17, and the constant term is 12. The product of 6 and 12 is 72, and two factors of 72, which sum up to negative 17, are negative 9 and negative 8. We therefore put negative 9 and negative 8 in place of negative 17. So our equation now becomes 6x squared minus 9x minus 8x plus 12 is equal to 0. We then put the first two and last two terms on the left-hand side of the equation in brackets and factorize them separately. The common factor of 6x squared and negative 9x is 3x. So the first two terms factorizes into 3x into bracket 2x minus 3 bracket closed. The common factor of negative 8 and 12 is negative 4. So the second two terms factorizes into negative 4 into bracket 2x minus 3 bracket closed is equal to 0. At this point, we put the factors in bracket and set it against the common terms in the brackets. So we have into bracket 3x minus 4 bracket closed as against into bracket 2x minus 3 bracket closed is equal to 0. I recommend that you watch our video lessons on factorization of quadratic trinomials for a better understanding of this section. If the product of two numbers is 0, it implies that either of them can be 0. So either 3x minus 4 is equal to 0, which implies that x is equal to 4 over 3, or 2x minus 3 is equal to 0, which implies that x is equal to 3 over 2. Therefore, the values of x for which the given algebraic fraction is 0 are 4 over 3 and 3 over 2. Good job. This should be enough for 0 algebraic fractions. Shall we now move on to undefined algebraic fractions? We have already learned that 0 divided by any non-zero number is 0. On the other hand, any non-zero number divided by 0 is undefined. Undefined means that the number cannot be determined. Therefore, any algebraic fraction of the form f of x over g of x is undefined if g of x is equal to 0. Putting it differently, since any non-zero number divided by 0 is undefined, an algebraic fraction can only be undefined if the denominator is 0. Thus, whereas in 0 algebraic fractions, the focus is on the numerator. In undefined algebraic fractions, the focus is on the denominator. To test this, let's try to divide 10 by some positive numbers in a decreasing order. First, we have 10 divided by 2 to be 5. What about 10 divided by 0.5? That will yield 20. What if we reduce the denominator to 0.0001? That will result in 100,000. Okay, let's reduce the denominator further to 0.000001. We will get 10 million. What if we reduce further to 0.0000000001? Guess what the answer is? That's 100 billion. So from this illustration, we notice that the lower the denominator, the higher the result in absolute terms. So should we change the denominator to 0, we will obtain a very huge figure. Since this cannot be determined, we use this symbol to mean the number is undefined. We can therefore determine the value or values for which a given algebraic fraction is undefined by simply equating the denominator to 0 and solving for the variable. Let's consider the following examples. Find the value or values of x for which the following fractions are undefined. Solution. Example 1. X over 2x plus 1. For the expression to be undefined, the denominator has to be 0. Therefore, we equate 2x plus 1 to 0. The next step is to solve for the variable x. To do this, let's first subtract 1 from both sides of the equation. This produces 2x is equal to -1. We can now find x by dividing 2 by both sides of the equation. This gives us x is equal to -1/2. Example 2. X squared minus 9 all over x squared minus 3x plus 2. Again, let's equate the denominator to 0. So we have x squared minus 3x plus 2 is equal to 0. This is a quadratic equation, and we can solve this by first finding two factors of the product of the coefficient of x squared and the constant term, which sum up to the coefficient of x. The coefficient of x squared is 1 and the constant term is 2. The product of 1 and 2 is 2. The coefficient of x is -3, and two factors of 2, which sum up to -3, are -1 and -2. We then put -1 and -2 in place of -3. So the equation now becomes x squared minus x minus 2x plus 2 is equal to 0. Let's now put the first two and last two terms on the left hand side of the equation in brackets and factorize each group separately. The common factor of x squared and -x is x. So the first group factorizes into x into bracket x minus 1, bracket closed. Again, the common factor of -2x and 2 is -2. So the second group factorizes into -2 into bracket x minus 1, bracket closed, is equal to 0. At this point, we put the factors in bracket and set it against the common terms in the brackets. So we have into bracket x minus 2, bracket closed, as against into bracket x minus 1, bracket closed, is equal to 0. Now, if the product of two numbers is 0, then either of them can be 0. Therefore, either x minus 2 is equal to 0, which implies that x is equal to 2, or x minus 1 is equal to 0, which implies that x is equal to 1. Hence, the values of x for which the given algebraic fraction is undefined are 2 and 1. Well done. This brings us to the end of today's lesson and the end of the topic Algebraic Expressions. In our next lessons, we will solve ample past SSSCE and WAS questions on algebraic expressions to give you an idea of the various question types and how best you can approach them. Kindly like and share this video and also subscribe to the TVTL's YouTube channel in order to receive notification on future videos. Thank you for watching and see you in our next video lessons.